So good afternoon. Let's start from lesson 8. Is the last technical lesson. In this lesson we are going to show how to create orthomosaic, ortho image, and how we can assemble all typical results from drone elaboration in a cartographic way. So let's restart from last exercise that in which we have just created a DTM, a digital terrain model with contours, and so we have just make the elaboration of dense cloud and filtering and selection data. So now to do this part is very important to go to build orthomosaic. So you can choose the surface in which by that the future orthomosaic obtain the height. In this case we can use clearly the damp surface that we have just elaborated. So we can choose how we blending in which way we are matching all photos. So mosaic, average, disable. In this case we want to construction to build a mosaic. So there are also other options to check. For example, enable all filling. Generally, when we project a data acquisition for build orthomosaic, we do a finger cross flight, so we don't it's impossible that we don't have overlap of photos, so it's very difficult that they have some hole to fill, but it's possible to do. So to prevent this, check enable hole filling, refine seamless. And so at the last you can choose the dimension of pixel. So the dimension of pixel in meters, that means the minimum resolution object that you can see in the future orthomosaic. So we can put 0.5 meters, and let's start elaboration. After finishing elaboration, we show the results on the model, on the ortho. And so on the ortho you see the results. So we can don't show the disable contours. Okay. Okay. And so we have the final results of this ortho photo. So the resolution you can change, you can you can test. In this case we have set it 0.5 meters, and so this is the orthomosaic. So finally, to send to your client or to your friends, or to share with some people the results of elaboration, you can export in different format. For example, for orthomosaic, orthophotomosaic, you can export as Google Earth, or you can export as TIFF PNG. is the same. You can do so. Try to export. So check the results, for example, in Google Earth. You can do the same for example, for the TM, and after we can export also the contour. Export layer. In this case, contour are vector layers, so we can export for example, in shapefile, DXF, JSON, or other format. Why is important to have updated orthophoto? Because we have more scope of this kind of job. For example, to check an area, to control, we have more type of application. So because you can with drone you can seize instead of other technique like remote sensing, you can seize now for tomorrow, when we do update the orthomosaic of area. So is a powerful way to control area, to control the evolution of area. So finally we can show how present the results in a cartographic way. So we are using a free software, QGIS. We are setting the system of reference. Lesson 8, exercise, results, and so you can load file, so first we load the raster, after we load the vector. So for vector file we have contour in S3 shapefile format. And at last we load the DTM, digital raster terrain model. So we save the project. We set a typical scale representation, for example 1:1. Assign to contour the label. and go to apply that. So if you want to show also the DTM, because it is a raster, you can make a palette of color, or you can show like a hillshade model in this case. So we set transparency for orthophotos. Okay, that's great. So try to print this project. Set the layout of, set the scale of print scale, insert north, so let's check to write coordinate system on the final print table. Insert graphical scale, if you want, insert title of the map. So we have just a cartographic way to represent this. And you can export in different format. For example, PDF. So that's clear. The software that we are using in this case, for example, Metashape automatically do the auto rectification. because if you remember the first lesson, when we see the parameters of acquisition, and we see, for example, how the single shot was acquired, you remember that we have a correction to do by pitch and roll. So it's very important that is automatically do, and is important that is do by ground control point. So it is important to have a grid or ground control point turn again. So we can obtain this result also with also in drone deploy. In drone deploy, you can choose a project, you can upload a data. So I have just uploaded data of this project, and we have the same results about the photos, the orthophotos. So that's clear, the powerful that is all image, all data is georeferenced, and I can do measuration. We can estimate it, for example, how road is long, how road is large, and so we can do, for example, we can estimate for example, the surface of the roof. If you go for the next course, for example, we have some tools application in G-System or also in QGIS that calculated the exposition of a roof and find all roof that is we have a good exposition to surf. For example, for application for photovoltaic. So it's very interesting, all the application that can be generated by drone. So all data is in this case georeferenced in UTM in this coordinate system. So also we have in drone deploy the base map perfectly is we have in this case we have why we have this collision, because the base map have different project system, GS 84 but in degree, not in meters, and so we have this displacement. Also here we can do some measuration of distance, for example. And if you make, if you have this is more interesting drone deploy, because if you make a line like this, that is an editable line. For example, if you are doing a railway or road project, you need, for example, a section. So immediately you can do a cross section, and they show here, they show all parameters, for example, length. So we can do cross section 01, cross section 01, the length of cross section, horizontal length, the surface length. Why these two lengths? Because one is, the first is the 2D length, the second is the 3D length. The medium slope and the vertical height. maximum vertical height. And you can export in CSV file. So we have all the coordinate in Excel format. So in drone deploy, also the auto rectification and the correction of pitch and roll will do automatically. So that's clear for specific application. In case you need to do other kind of job, you have to use a very high other software performance to stay more accurately the auto rectification. So this is the last practical lesson. The next lesson is talk about the difference between the drone application and the remote sensing application, and make a comparison between the cost of the different technique and also the prospective application that have the different technique. And finally we have the test. So thank you guys for attention.